Welcome. This question says a student pulls a 4 kilogram bag 3 meters across a level rough floor by applying a steady force of 6 newtons at 20 degrees above the horizontal. How much work was done by her 6 Newton pulling force? Here's a diagram showing it. I don't like using diagrams I'm given. Often they're not the best diagrams in the world. So, and again, I like to make small boxes and big arrows. So I'm going to do that as a 6 Newton. I have my my normal force. My weight, of course, is going to be 40 newtons because this was 4 kilograms. There is a frictional force which is opposing my tendency of motion. It's a rough floor. And then what in addition I have is this displacement, which is 3 meters. Notice the general direction of the applied force and the general direction of the displacement in the same direction. So I have two choices here. I can intellectually I can resolve my force in the same direction as my displacement. And if I do that, I know that this is 6 cosine 20 degrees because this is 20 degrees here. And then I say, oh, work is equal to the component of the force in line with the displacement times the displacement. And so I would say work is equal to 6 cosine 20 times 3. And if I work that out, that's work is equal to, it's going to be 18 times cosine of 20, which is 16.9 joules. So there's an answer. Intellectually, I could do something slightly different. And let me just redraw this, the important bit of it anyway. I'll probably draw it all. And then we have, this guy was 3 meters here. And this guy was 6 meters up here, 6 newtons up here, 6 newtons. And what I could do instead is find the component of the displacement in line with the force. And this here would be 3 cosine 20 because this displacement was 3 meters. And if I did that, then I would say, well, work is equal to F times D cosine theta. So work is equal to, it's going to be 6 times 3 cosine 20, which again is 18 cosine 20, which again is 16.9 joules. So the important thing to realize is that the force and the displacement must be in the same line, or the force and the component of displacement must be in the same line, or if you like, the displacement and the component of the force must be in the same line. But you can't have any old force and any old displacement. And that's the most common mistake, is people will just take the 6 and they'll take the 3 and they'll say, oh, work is force times distance, and they'll just multiply those guys together and get 18 joules. But it's not any old force and any old displacement. They have to be the components along the straight line. So there we have it.